Let's take a look at some sample problems from section 11.2 dealing with events involving not and or. And in the textbook, this is the 12th edition. I'm on page 594, and I'll begin with number 2, dealing with the definition of mutually exclusive. In number 2, it says determine whether the events are mutually exclusive. Jean Jalufka earned her college degree several years ago. Consider the following 4 events. Her alma mater is in the East. Her alma mater is a private college. Her alma mater is in the Northwest, and her alma mater is in the South. Are these events all mutually exclusive of one another? So our question deals with, can the two occur at the same time? Can any two occur at the same time? Well, the East, the Northwest, and the South, you might say that they wouldn't overlap, although you could talk about something being the Southeast, which could overlap. But the big one that stands out to me is a private college could be in any of those locations. So because that could occur at the same time as the locations, I would say no, it's not mutually exclusive. Okay, moving on to number 4. It says, for the experiment of rolling a single fair die, find the probability of each event. Okay, so a probability that it's not less than 2. So another way of saying that it's not less than 2 would be to say it's greater than or equal to 2. And so that would be a 2, 3, 4, 5, or 6. So that's 5 out of 6. And it's easy to get tied up with this not situation. It's odd or less than 5. So we can do probability of odd plus probability of less than 5 minus the ones that we and less than 5. So there's 3 odd numbers out of the 6. Less than 5, there's 4. The odd numbers less than 5 would be 1 and 3, so there's 2 of those. So we get 7 minus 2 would be 5, 6. Probability of odd or even. Okay, these are mutually exclusive, so they don't overlap. We can just add probability of odd and probability of even, because the probability they both occur would be a 0. So that's 1/2 plus 1/2, 3/6 plus 3/6, which would give us a 1. All right, so in number 10, we're dealing with cards now. It says, for the experiment of drawing a single card from a standard deck of 52, find the probability and the odds in favor of each event. All right, that it's not an ace. That's going to be 1 minus the probability it is an ace. And so how many aces do we have? We have 4 out of 52. So that's actually 1/13. So 13 thirteenths minus 1/13 would be 12 thirteenths. Okay, still dealing with the card situation. We're drawing 1. Whoops, I didn't do the odds. Let me go back and do the odds. Odds in favor, all right, would be 4 to 39. let's see, 4 to 48. So the odds in favor of getting a card that is not an ace would be 48 to 4, which is 12 to 1. Okay, now let's go to number 12. Club or a heart. Again, these two are mutually exclusive. We can't draw a single card that is both a club and a heart. 1/4 of the cards in the deck are hearts and 1/4 are clubs. So we get 2/4 or 1/2. So the odds in favor we have 26 to 26. 26 cards are either clubs or hearts to 26 that aren't, or if we reduce it 1 to 1. Okay, in 15, we're still in the same group, neither a heart nor a 7. So if we consider we've got 13 hearts, including 1 7, plus 3 other 7s. So that gives us 16 cards, and 52 minus the 16 leaves 36 other cards. So the probability of getting not a heart and not a 7 would be 36 out of 52. 4 will go into both of those. So I get 9/13. Okay, and part B is going to be 36 to 16. 6. Let's see, we can divide 4 into both of those, so that would be 9 to 4. Would be the odds in favor of not getting a heart nor a 7. Okay, let's go to number 16. We're rolling dice, and you may want to refer to the table back on page 527, table 2, for rolling the dice. What is the probability of getting an 11 or a 12? So if we look back at the table, we have a 5-6, a 6-5, and a 6-6. So it's 3 out of 36, which is 1/12. So that's probability of 11 or a 12. And let's do 18 as well. An odd number or greater than 9. Okay, so if we look at it, the odd, we see half of the table gives us odd sums and half of the table gives us even sums. So we have 18 that give us odd. All right, and greater than 9. Some greater than 9. Some greater than 9. Okay, there's the 9. So it looks like we've got a sum of 10. 1, 2, 3, 11, 4, 5, 6. Minus odd, sum, and greater than 9. We do have some overlapping. We have 2, the 11s. So 24 minus 2 is 22. And that would be 11 out of 18. 11 out of 18. Okay, I think I'll stop at this point and continue the remaining sample problems in another video.